everyone. So today we are going to solve a few questions from Codeforces around number 683, Division 2. This contest was hosted by Meet IT. So in this question, let's start. So the first question was add candies. In this question, we were given a number n. So this implies that we have n bags numbered 1 to n, and each bag has so they were number 1 to n. So each bag each ith bag had I candies. So basically we have this sort of candies. So our task here is to perform m operations uh, and in an order. So like for each jth operation, j belonging from 1 to m, what you have to do is select any one bag, and you have to add j candies to every bag except this bag. So for example, my n is equal to 3, and suppose I perform j equals to the operation first time on bag number 1. So what I will basically do is I won't add any candy to this first bag, but add one candy to each all other bags. So that's what I'm going to do. So our final task is to perform m such operations and equalize the amount of candies in each bag. So this is a pretty straightforward question. So what we will do is, suppose we have n up to n. So we can make the number of candies in each bag equal to summation n, that is n plus n into n plus 1 by 2. And how are we going to do this? So for example, we will select the first bag in ith operation, and due to that, what will happen is every other bag will get 1 except for the first bag. Then we will select 2, and every other bag will get 2 instead of this bag, and so on. So what will happen is, suppose my n is equal to 3. So I perform let me show it in a form of matrix. So suppose I have n is equal to 3. So I choose a bag 1, and I perform the first operation of bag 1. So every other bag will get, so this is bag 1, bag 2, and bag 3. So if I perform first operation on bag 1, every bag will get 1. If I perform operation 2 on bag 2, every bag will get 2 except the second bag. And when I perform operation on bag 3, every bag will get 3 except the last one. So basically the sum of all the bag will be equal to 6. So this is the pattern we are going to follow. So our output format is output format expects us to write the number m, how many operation we are going to perform, that is going to be n, and we have to mention which bag number are we going to use. So that is pretty simple. All we have to write is all we have to do is print the number 1 to n with spaced integer 1 to n, and that's it. That's our first question done. So now we'll move on to second question, that is numbers box. So in this question we have a matrix of size m cross n and which have integers, can be positive as well as negative. So in this question, what you have to do is, we can select any two adjacent boxes and multiply both the elements in the matrix by -1. So for example, we can select this two box and multiply with -1. So this number will become 1 and this will become -1. Okay, so we can do this operation, and our final objective is to maximize the sum of this matrix. Now there are few observations we need to take care about. we need to make in order to solve this question. The first observation is in the question they didn't ask us how many that they didn't limit us by how many times we can perform this operation. This is the first observation. And the second thing is, suppose I have a matrix like this. So this is the example test case I will take one. So if I take this matrix and take this two adjacent element and multiply it by -1, this number will become positive and this will become negative. And now if I select this matrix and perform the operation, this number will become -1 and this will become +1. So what we can observe is a minus sign can the minus sign traveled from this element to this element. So basically what we can do, so basically if we have uh, even number of negative signs in our matrix, so suppose we have some matrix, we have a -1 in this corner, and we have another -1 in this corner. So I can literally like this minus sign can travel via some part to one of these adjacent column, and we can select those two column to perform the operation, and we will eventually get rid of all the minus sign. But what if we have odd numbers of negative sign? So odd number can be represented as 2k plus 1. We can fix 2k number of this many number of negative sign by this traveling and this method. And for the last negative sign, what we can do is we will make this negative sign reach the smallest number in the number with the smallest absolute value in the matrix. So basically our code um, our code will look like, so first we'll count the number of absolute values, we will count the number of negative signs in the matrix. If it is even, then we'll print the sum. If it is odd, then what we are going to do is we'll print sum minus 2 times the minimum absolute value, the minimum number, that is the smallest absolute value. For example, if we have matrix like this -1 2 3 4, so one will be our uh, absolute minimum number, because mod of -1 is 1, which is less than mod of all the other elements. So if we suppose if we had no negative sign over here, then our sum would have been 10. But because this guy will become negative if we have odd numbers, so our sum will become 8. So we'll have to reduce twice the number of smallest absolute number from the total sum. Okay, so this is how we are going to solve the second question. Now let's move on to the third question. So welcome to question number 3, that is a knapsack. In this question we are given an integer n and w, and w is the weight of the knapsack, and we have another array, items array of size n, which gives information about the weight of each item we have. So in this question we have to choose some of the items from this array, such that the weight after filling them in the knapsack, the weight of the knapsack should lie between these constraints, that it should be greater than half of the weight capacity of the knapsack, and obviously less than the capacity of the knapsack. So how are you going to solve the question? So let's look at the items. There can be three types of items three types of items based on their weights. So one which lies between so category 1, which lies between this constraint, like lies between this domain, which lies in this category, that is their weight is greater than 0 and less than the low like the half of the capacity of the knapsack. Another category is one which strictly which lies between the required capacity, that is category 2, and the third category which is greater than the capacity of the knapsack. So these items we are not concerned with, but we are concerned with these two types of item. So what I am going to do is I will iterate over the array, traverse the array, and check if any item of category I2 exists. If they do, I will directly print them. Otherwise, what I am going to do, I will I will iterate over the array once again to check items of category of this first category, and I will greedily sum them. So why am I doing this? And why am I doing this actually? So here's the reason. So suppose I have an item of category I2, and and suppose I consider a case where I have an in the array I have an item of category I2 and another case where I don't have this. So if I greedily add, so suppose in this case where I have item of category I2 and I greedily add over the uh, items of type I1, what I might eventually reach a case where the sum of these two items, that is type I2 plus I1, can exceed W. So I have to treat these cases separately. Okay. So what I am going to do is I will write the final pseudo code over here. So for traverse over the array, and if I get any number which is of category which falls in the category I2, uh, uh, which falls in the category I2, I will print one, that is the number of item I am using, and print the index of one indexing index of this item. So I will print I plus 1. So otherwise what I will going to do, I will initialize a sum, and sum equal to 0, and traverse over the array once again, else, and check if and I will greedily add I will greedily add items of category I1, that is weight less than half the capacity of the array. And at a point, if I reach if my sum reaches the size of the if the sum of my array reaches the required condition, I will break and print the number of items I've chosen and the index of them. So that's what I'm going to do with this question. So I hope you understand why I treated both of these cases separately, uh, because if I choose any item from category I2 and one item from category I1, their sum can be greater than W. So this can be a problem. So that's why I handle these cases separately.